So I hope you're not playing music while I'm talking during the lecture. Because I mean, how are you supposed to pay attention to me and listen to music at the same time? Okay, so let me pull up the PowerPoint here. So just a couple of things before we get started. Remember, there is a test on Wednesday. The first PowerPoint that we cover today, that will be the last material on the test for Wednesday. And then when we go to the next PowerPoint, none of that stuff will be on test one. That will be on test two. If you have questions about anything on the test, please contact me. Please schedule an appointment with Michael, our SI, and he will help you. We will help you with any material. The test, we will be using ProctorU, which means you will be recorded when you take the test. And it also means that I can watch you anytime I want when you take the test, and you won't know, kind of creepy. But I will give instructions for ProctorU. I'll make an announcement about that later today. Lastly, when I'm doing the lecture and when I'm giving you time to do the problems, please do the problems. Think of the skills we're learning as like learning an instrument, right? You cannot learn how to play the guitar by somebody showing you chords and you thinking that you're just going to absorb that information via osmosis. You have to pick up the guitar, do the chords, get the muscle memory. Same thing with chemistry and math. By watching me do the problems and not attempting them, you're not going to learn this. You don't have the memory, the muscle memory in your mind to do this. So please just make sure you're doing this. Make sure you are attempting all the problems when we're doing that time. All right. So we left off with question 2. I did A and C, and I need to do B and D. Since we already did A and C, hopefully some of you already went ahead and tried B and D. If not, no worries. But I'm just going to go through them relatively quick because we do have, later today, we have another balancing that we'll get to, but I just want to give the answers to B and D. So B, remember, the first thing we do when we're balancing equations is that we write down the elements in our reaction. So we have 3 elements. We have zinc, we have hydrogen, and we have chlorine. Then I make a little ledger. Reactants on the left, products on the right. Then I just simply write down how many atoms are in each side of the equation, where left-hand side is reactants, right-hand side are products. So 1 zinc on the left, 1 zinc on the right. Hydrogen, 1 hydrogen on the left, 2 on the right. Chlorine, 1 on the left, 2 on the right. And so remember, the whole goal of balancing equations is to have all the numbers match up both on the left and the right, because we can't create or destroy matter. So whatever atoms go into the equation must come out. So B is super simple, right? We have 2 hydrogens on the right, 1 on the left. 2 chlorines on the right, 1 on the left. Well, if you just put a 2 in front of 2 HCl on the left, you now go to 2 hydrogens and 2 chlorines. And that's all you need to do. So balancing equations don't always have to be, they don't always have to be like hard or in depth. Sometimes they're easy like that. D, though, D is a little more in depth. So let's go through D. So let me clear B because I need some space. So D or B was just simply a 2. D, the elements we have are Al, C, O, H, P. So we have 5 elements now. That was not a good line. Reactants, products, 2Al on the left, 1 on the right. 3 carbons, because this 3 is being distributed in the parentheses. 3 carbons on the left, 1 carbon on the right for CO2. Then we have oxygen. We should have 13 because 3 times 3 is 9, plus 4 is 13 on the left, then 4, 6, 7 on the right. Hydrogen, 3 on the left, 2 on the right. Phosphorus, 1 on the left, 1 on the right. Okay, so with this many elements, again, let's go back to what I said on Wednesday. To start balancing, you generally want to start with the element that only appears once on each side of the equation if you can. And so we have 2 choices for that. We have aluminum and we have phosphorus. Phosphorus is already balanced, so I don't need to do anything to that. Aluminum's not balanced though, so I need to put a 2 on the right. So when I do that, aluminum becomes 2. Aluminum's good to go, that's balanced. Now, we do also unbalance phosphorus though, because we make 2 phosphorus. And since we're doubling AlPO4, we have added 4 more oxygens. So I add 4 more oxygens to my 7 to make 11 now, okay? So that's our first move. So let's try and keep the same rule. Start with compounds that only appear once on each side of the equation. That's phosphorus now, because aluminum is taken care of. But now we have to rebalance phosphorus. 1 on the right, or 2 on the right, 1 on the left. So I need to make 2 on the left. So phosphorus goes to 2. Now we have 2 molecules here. So I just added 3 more hydrogens. So hydrogen goes from 3 to 6. I added 4 more oxygens. So oxygen goes from 13 to 17. So that's a good way you can keep track of your changes. I added this many more elements, right? I added 4 more oxygens. I added 3 more hydrogens. All right, so that's taken care of. Now, the next element that appears only once on each side of the equation is carbon, all right? Aluminum, taken care of. Phosphorus, taken care of. Carbon is now our next element. So 3 on the left, 1 on the right. That's an easy change. I need 3 on the right as well. So carbon goes to 3. And now I just added 4 more oxygens. So you might be tempted to say I added 6 oxygens, but it's only 4, and I'll show you why. All right. We started with 1 CO2. Now I'm saying we have 3 CO2, right? So this was my original CO2. These are my new CO2s for a total of 3 CO2s. So I added 4 new oxygens to my reaction. So 11, we had 11 on the right, plus 4 is 15. Okay? So aluminum, carbon, phosphorus, all balanced. The only thing not balanced is hydrogen and oxygen. So let's do hydrogen. 6 on the left, 2 on the right. Well, there's only 1 compound with hydrogen, so I'm going to put a 3. 3 times 2 is 6. I added 2 more oxygens for the same reason as the CO2. The same logic applies for H2O, where I had 1 original. I added 2 more for a total of 3. So I add 2 more oxygens for 17. That is a balanced equation. So your coefficients are 1, 2, 2, 3, 3. Are there any questions about balancing equations? Anything at all? How we do it, the logic of it? Because I will guarantee you on the test on Wednesday, I will give you at least one equation to balance. That is my 100% guarantee. I will give you something and say balance it, and you have to tell me what the final coefficients are. So let's see here. Okay, so if there's no questions, let's move on. The last thing we have to talk about for this PowerPoint are carbon compounds. And the way you name carbon compounds, let's just start with the base name over here on the right. You count up how many carbons there are. Based on how many carbons there are, you give it a name. So methyl, or meth rather, means you have one carbon. Eth means two carbons. Prop, bute, pent, hex, hept, oct, non, dec. And these aren't just carbons, I should actually specify. These are carbon hydrogen compounds. So that's what I mean by hydrocarbon. It's the number of carbon and hydrogen compounds that you have. For example, propane. So those of you who like to use propane and propane accessories, that is 3 carbons and 8 hydrogens. So there's 3 hydrocarbons. Ethane has 2 carbons. Ethene also has 2 carbons. So you can see here that not only do we care about the first part of the name, we also care about the last part of the name. So the way to name a carbon compound is count up the hydrocarbons and you get the first part. The second part, the ane, ene, or ine, is due to bonding. If your carbon compound only has single bonds, and this is a single bond, just a one line, if you only have single bonds, then it ends in ane. If there's at least one double bond present, it ends in ene. If there's at least one triple bond, so 3 lines, triple bond, ends in ine. So A, E, Y are the 3 ways you can name it. And to further complicate things, your compounds will have their name changed based on what other groups are attached to them, which are given here. So alcohol. Alcohol just means it's a hydrocarbon compound with an OH. So ethanol is the stuff that you drink and will get you drunk. If we look at ethanol as eth, so that means 2 carbons. All means OH, ethanol. That's how we get that name. And there's a bunch of the other ones here. Ethers, aldehydes, ketones, carboxylic acids, esters. Those of you who are gonna go on to organic chemistry, you're gonna learn all of this. All of this information is basically organic chemistry, like the first, I don't know, week or so of organic chemistry. What I care about right now is, do we know what an hydrocarbon compound is? Do we know, can we look at a single bond, double bond, and a triple bond? And can we name it single bond, double bond, triple bond properly? I'm not going to have you memorize this table 3.7. That's more for organic chemistry. Is this slide from chapter 4? I don't know what chapter we're in actually off the top of my head, because I usually go by page numbers, so I'm not sure. It's from the PowerPoint from Wednesday. I'll say that. But yeah, so know ein, ein, and know if something's a organic compound or not. And we'll get into what's an organic compound in a second here. Okay, organic compounds. A compound is generally organic if it has carbons in it. So if it contains like carbon, nitrogen, hydrogen, oxygen, phosphorus, sulfur, mainly if it has carbon and then like any of these, we call it organic. There are exceptions. Cyanide, CN, that's inorganic. Carbon monoxide, carbon dioxide, they're not organic. Really, I guess for organic, you need a hydrocarbon. You need a carbon and a hydrogen for it to really be an organic compound. You see, cyanide doesn't have that. Carbon monoxide doesn't have it. Carbon dioxide doesn't have that. And since we're talking about organic compounds, I just want to share a fun fact. Well, I don't know if it's fun, but an interesting fact. So organic food has been on the rise for the last 2 decades now, a multi-billion-dollar industry. Every time you go into the grocery store, you will see a little section that's organic, where everything costs like $1 more. And there seems to be a misconception around the general public. What does organic mean? If you ask the general populace, what does organic mean? I think most of them would answer, it means no pesticide, which is untrue. So what I'm showing here are organic pesticides, right? So organic food uses pesticides. They just use pesticides that are organic. And organic just means has carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. They're not, it's funny in that even though they're natural, it doesn't mean they're safer. It's just that they're organic compounds. But yeah, that I just always find that funny when I go shopping or I talk to friends who are super inorganic. And you're like, you know, they have pesticides on them, right? And they're like, I think you're wrong on that. Is it better for you? No, that's the thing, right? It's marketing. There's no proof that organic pesticides are better than you than regular pesticides. And a lot of the times, organic pesticides don't work as well as non-organic pesticides, so you have to add a lot more to your food. And they're not regulated as harsh. I don't actually, so I don't know if this is 100% true anymore, but I know when I was researching this originally, they aren't as regulated as non-organic pesticides. So you can just add a crap ton to your food. Faster decay of the organic pesticides, that could be true. I don't actually know that, so I can't comment one way or another. I have not looked into that. But yeah, if you're in the organic food, that's fine. Just don't be into it because you think it doesn't have pesticides. That's it. That's my fun fact for the day. All right, but all we need to know is, are these compounds organic or inorganic? So A, B, C, and D, what I want you to do is simply tell me, are these organic or inorganic compounds? Now I'll give everybody a minute or so to do that. Yes, this PowerPoint from Wednesday is the last one that will be covered on the exam. When we go to the next PowerPoint today, that will not be covered on the exam. But let's go over this relatively quickly. Calcium, I just forgot his name, CaCO3. So there's a carbon, but there's no like hydrogen, so it's not a hydrocarbon. So this is actually inorganic. This compound is an inorganic compound. C4H8, carbon, hydrogen, organic. C4H6O6, carbon, hydrogen, organic. Lithium fluoride, definitely inorganic. Yep, so when you're doing organic versus inorganic, look for those carbons, look for those hydrogens. Yeah, so you need to have, if it's just like carbon and oxygen, yeah, that's not organic. Like carbon dioxide is not organic, technically. I believe that's how it goes. Usually you're looking for a hydrogen as well. Mainly organic does just mean carbon, but there are like cyanide is not organic. So you need to add, usually what I look for is carbon and hydrogen. All right, I believe, oh, I have one more question, really quick. Just so we know which one's an alkane, which one's an alkene, which one's an alkyne, so A, B, and C. And the L, we didn't really talk about this yet. ALK means hydrocarbon. So which hydrocarbon's an alkane, alkene, alkyne? And D, add an alcohol group. So what does it mean to be an alcohol? So just do that really quickly, and then we'll move on to the PowerPoint for today. Yes, double bond. If it has a double bond, it's an alkene. Single bond, alkane. Triple bond, alkyne. Add an alcohol group. An alcohol simply means OH. So there's an OH on the third carbon. Another fun fact. This is ethanol. This will get you drunk. This is methanol. This will kill you if you drink it. Notice there's only one carbon difference, and that's all that matters when it comes to biochemistry. One carbon makes a huge difference between something that's only minorly, well, something that's kind of toxic to us in ethanol and something that's super toxic to us in methanol. But yeah, that's the only difference between ethanol and methanol. There's your alkene, alkane, alkyne, and alcohol group. Any questions about organic compounds? Otherwise, we will move on to today's material. So let's stop sharing this. Let's screen share something new. 918. Yeah. So what we're going to talk about is reaction stoichiometry, right? So we learned yesterday and the beginning of today how to balance equations. And to balance equations, we were putting numbers in front of our compounds. These numbers are stoichiometric coefficients. And they tell us how molecules react in a reaction. So if we just look at this, this is saying that two molecules or 2 moles of C8H8 react with 25 molecules or moles of oxygen. When we react these, we make 16 molecules or moles of carbon dioxide and 18 molecules or moles of water. So the coefficients in front of the molecules tell you how these molecules react, what number they react in, or what number they're produced in. And this whole idea is stoichiometry. Stoichiometry is relating the numbers in front of the compounds and to make sense of it and to use it. Anything with the numbers in front of the compound, we just call it stoichiometry. What are your stoichiometric coefficients? So here I have an unbalanced equation for you where we take hexane and we light it on fire. The first thing I want you to do, which hopefully everyone's capable of now, another practice, balance hexane. Balance this equation for me. Then, once you have that, see if you can use stoichiometry, like the thing I just said, talked about, to tell me if I have 7.2 moles of hexane, how many moles of O2 do I need? So I'm going to give everybody a few minutes to try and tackle that. Again, if you have questions, if you have answers, if you have anything, please let me know. Will you ever come into a situation where a formula cannot be balanced? Not on anything I give you and not on anything in reality. If you come to a situation where something's not properly balanced, either you did a mistake balancing it, or whoever made the question made a mistake and it can't be balanced. But in reality or anything I give you, no. So hopefully everybody's gotten to the part of at least making your table where you just simply write down your elements. If you have not gotten that yet, well, that's where you should start. Make your table. Tell me how many carbons are in each side, how many hydrogens, how many oxygens, and then go about trying to balance it. Whoops, I did not mean to do that. So we look at this, 6 carbon on the left, 1 on the right. 14 on the left, 2 on the right. 2 on the left, 3 on the right. Let's try to balance this. So carbon only appears once on each side. So that's what I would go for first. 6 carbons. So 6 carbons, and I just added 10 more oxygens, 13. All right, so carbon's good. Now we need to go to hydrogen. Well, we can go to oxygen, but let's go to hydrogen. 14 on the left, 2 on the right. That's an easy fix. Put a 7. 14 hydrogens. And we just added 6 more oxygens. So a total on the right would be 19. Here is where we get to a problem. I have an odd number of oxygens on the right and an even number of oxygens on the left. And so the only numbers I can change my oxygen on the left are by even numbers, meaning I can never get to 19. The only way you can get the 19 is if you said 9.5, but you can't do that. You can only use whole numbers. So it can't be 9.5. So this is, when you run into this situation, what you need to do is you need to unbalance something, because oxygen cannot be balanced anymore. So I need to unbalance my reaction. I need to do something that's non-intuitive. And so when I run into a situation like that, I'm going to go to my first compound, the compound I balance first, and then try to unbalance it. And what I mean by that is carbon was my first compound. It is balanced, but I need to increase things if I want to balance oxygen. So what I'm going to do is I'm going to put a 2 on the left. And you can do that. You can put any number in front of any compound that you want. And so if I put 2 in front of C6H14, I now go to C12, and I would go to H28. Why is oxygen 3 on the product side? CO2 plus H2O is 3 oxygens. Not 30, 3 oxygens. That's why it was 3 originally. Okay. Yeah. So let's now balance carbon. So I unbalance it. Let's rebalance it. So I need 12 on the right, so 12. My carbon are now rebalanced. And if you were to count up all of your oxygens, You have 24 from CO2 plus 7 from oxygen, which is 31. Now we need to balance the hydrogens, right? 28 on the left, 14 on the right. So I need a 14 here to make 28. When I do that, I just added 7 more oxygens. So in total, I have 38 oxygens. I have an even number of oxygens. That's good. Now I can balance my oxygens. 19. 19 times 2 is 38. That is a balance equation. So when you come, like I said, when you come to a situation where you can't balance it anymore and you're kind of stuck, go back to your original compound and try to unbalance it. All right, go back to the original molecule that you targeted as being the easiest, unbalance it, and go from there. And just as a note, this type of equation would be the hardest thing you would have to balance for me. I will not give you anything more difficult than what we did right there. All right? Any questions about balancing that type of equation? Always start with carbon? No, always start with the element that only appears once on each side if you can. So you could have started with carbon or hydrogen. Either way would have worked. I just started with carbon. But yeah, generally try and pick the element that only appears once on each side. One sec. Gotta answer this message. All right. Now that we have a balance equation, let's see how stoichiometry works, right? I have 7.2 moles of C6H14. How many moles of O2 are required? This is unit conversion. I'm converting from C6H14 to O2. My coefficients tell me how to convert. That's what's going on here, right? So I have 7.2 moles of C6H14. For every 2 moles of C6H14 I use, I need 19 moles of O2. C6H14 cancels out. I'm left in moles of O2. Now, when you switch between compounds, you must be in moles. Switching compounds, you must be in moles. You cannot be in anything else. And the stoichiometric coefficient will tell you what the relationship is between these compounds. For every 2 moles of C6H14, there's 19 moles of O2. We get that from the balanced equation. Now we have our train track set up, multiply at the top, divided by the bottom. And we get 57.6 moles of O2. And sig figs, there should only be 2 sig figs because it's 7.2, should be 58 if I did my calculation right, which I'll double check right now. Questions about that lovely problem? Combining multiple lectures into one problem. Oh, did I not calculate it right? 7.2 times 19 divided by 2. 68.4. My bad. I wrote it down wrong. 68.4, 69. Let me double check. Yeah, so the person I said, so 68. So the person I said not quite to, I'm sorry. That was I made a calculation error. That's why I always should double check my work. That is 68. Questions about that? Units are moles of oxygen. 68 moles of oxygen. You can get the unit from the way the trade track is set up, because the only unit that's not crossed out are moles of O2. And again, balancing equations will be on test 1. Stoichiometry, using those, will not be on test 1. That'll be on test 2. Any other questions? If not, we will go on to our next problem, which will be our final problem for the day. Okay, here's the same exact thing. I already balanced the equation for you. What I want you to tell me is, if I have 2.87 kilograms of N2O5, how many moles of NO2 do I make? See if you can figure this out. How many moles of NO2 will I make given that weight of N2O5? And as a reminder, to switch compounds, you must be in moles. And another hint, if you forgot, to switch between grams and moles, you need the molecular weight, right? That's how we convert between grams and moles again, which we learned about, I believe, earlier this week. And since I give you a weight of N2O5, the first thing you need to do for me is calculate the molecular weight of N2O5 using your periodic table. So we look at, just to make sure my mic was on. So we look at the periodic table. Nitrogen, 14.007. Oxygen, 15.998. So molecular weight. So we have 2 nitrogens, 2 times, this is nitrogen, 14.007 plus, and we have 5 oxygens in N2O5, 5 times 15.998. That equals 107.959 grams per moles. So that's the molecular weight of N2O5. You will have to be able to calculate something like that on the test. Again, I'll make that 100% guarantee. I will ask you a question of what is this molecular weight? And you cannot look it up on the internet because the program we're using knows when you open up browser tabs. So make sure we have that skill down. Okay. Now I have a weight of N2O5. We're more or less done with the problem once we set it up. So let's just think about this conceptually. No numbers. I'm given a weight of N2O5. My final answer, based on this question, I want moles of NO2. So I have to figure out how to switch from kilograms of N2O5 to moles of NO2. Well, like I said, the only way to switch compounds is that you need to be in moles. So I know I have to get to moles of N2O5, right? That's the only way I can switch between compounds. They both have to be in moles. So I know I need to convert to moles of N2O5. And hopefully we know the only way to convert from moles to grams, so we need to be in grams, is our molecular weight. So molecular weight tells us how to convert from grams to moles. Stoichiometry tells us how to convert from moles of one compound to another. And the metric system tells us how to convert between kilograms and grams. So again, like I said on Wednesday, we are building our foundations early on in the course and using those foundations to do chemistry. So hopefully we have strong foundations. So we start with 2.87 kilograms of N2O5. For every 1 kilogram of N2O5, that's 1,000 grams of N2O5. Metric system. Okay, molecular weight. I want to go to moles now. That's what we just calculated. For every 107.959 grams of N2O5, I have 1 mole of N2O5, right? So now my unit is moles of N2O5. So we're right here, and I want to get to moles of NO2, so I need to use stoichiometry. For every 2 moles of N2O5, there are 4 moles of NO2. Moles of N2O5 cancel out. My final unit is moles of NO2. Multiply everything on the top, divided by everything on the bottom. Originally, I got 53.3. Let's actually check that that's right, because apparently I can't do calculations all that well. So 2.87 times 1,000 times 4 divided by 107.959 divided by 2. Yeah, roughly 53.2, 53.3. So I think it should actually be 53.2, but that is close enough. Questions about these problems? All right, well, if you do have questions, please do let me know by email. Again, this will be the last time I'm going to harp on it. But, you know, moving forward in this class, these problems will be more complex like this, where we're going to use parts from previous lectures. So please, if you have not been doing so, make sure after like every lecture, you go back and review the problems without the answer in front of you, and you know how to do it. All right, that's what I would do. If you do not know how to do it, reach out to somebody who can help. The tutoring center can help. I can help. Our SI leader, Michael, can help. Because if you are planning to just cram for our tests, you are not going to do well. I can guarantee you, because my test average for Gen Chem 1 is roughly like a 63%. That's not saying that people don't get A's. Usually, 20% of the class gets A's, because 20 those people study hard. They do this over time. A lot of people don't, though, and that's what brings the average down. So make sure you're putting in the time, you're putting in the effort. This is like learning a guitar. It's not easy, but it is all math. It is all logic. So make sure we have the resources for you. Make sure you are utilizing those resources. Ask for help when you don't understand something. That's the only way I can help you. I am willing to give you as much time as needed, but please do reach out. Yes, tutoring is online. So hopefully they will be ready to go, because we do have people who can help with this in the tutoring center. Michael can help. He has office hours and all that. If you don't want to talk to me and you want to talk to somebody who took this class last year, email him, talk to him. He's a very friendly guy. If you think I'm too intimidating for some reason, me and my Hawaiian shirts, talk to him. He took me last year, so he knows what's going on. He knows what to expect. Otherwise, talk to me. But that's the last I'm gonna harp on that, because nobody wants to hear all that harping. Otherwise, I'll put a homework up that will be due on Sunday, as always. Test on Wednesday. I will put up more information to how to take the test, what you need to do. Otherwise, I hope you all have a good day and a good weekend, and hopefully I'll see you on Monday. Take care, everybody.